All right, guys. I think we kind of devolved into other topics.
Probably on a test, I would just do the same.
Yeah.
All right. So hopefully this problem is like now trust me, you could totally understand this and put M14 without thinking. I get that. And I should be able to tell over the course of a long test if you really believe that's true or if that was a momentary brain fart, right? This ain't M14, right? This, of course, is M to the 9th. I like it. This is illustrating the next higher operation, right? So this we already did this one. Well, I did it with somebody else. A to the 20th. I like it. And again, every single rule is a consequence of us saying, I don't want to write 20 A's. A times A times A times A times A times A. I'm tired already. I want to write that in a more concise way. The minute I do that kind of thing, I need to develop rules of how to handle that. Right? All right. Yeah.
When you're talking to someone, would you say A to the 20 or A to the 20th?
I would say A to the 20th.
Okay.
Now, in the course of doing a problem, I could say M9, and you all know what I mean, right? It sounds like some weird
Yeah, I'm just kind of asking.
horror movie director.
Like, when you're talking, when you talk to someone like
M9 Shmuel. All right, what about like Brett Favre? This problem, I saw most of you guys doing something which is fine, but it would be a lot easier to simplify the inside. That's why I say you do this outside power last. You don't have to. You could totally do it first. But I'd rather have less shit to cube. Right? So let me do it both ways. So 2 cubed is 8. Q cubed cubed is q to the 9th. I like it. And cube 5 cubed. See what I just did? I did 15. And of course that would be 8q to the 24. Now watch. If I did it the other way, how many q's are on the inside? 8. 2 cubed is 8. Q 8 cubed is q to the same answer. Is that cool? So it kind of sucks sometimes that there's so many ways to do a problem because people sort of do half of one and half the other and the whole shit goes to bad. Half of this way, half of that way equals one bad problem. Yes?
I don't know how I got 6. I got 24, yeah. But I got
Oh, you did 2 times 3 instead of 2 cubed. 2 cubed means 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. Yeah. Let's see. Okay, good. Where are we at? 5. All right. This problem does not include the idea of FOIL yet. We're not there yet. More importantly than just we're not there yet is, what's the only operation in this whole damn thing? Multiplication, right? So let me see. If I said, what is 2 times 11 times 5? I would not do it in the order they gave me. How would I do it? What's nice in there? 11 times 10, right? Why am I allowed to do 2 times 5? Because it's all multiplication. I can change it around. So I'm going to do 3 times, what's the only other thing I can actually do something? 5. 3 times 5, I can do that. 15. B to the 4th times B squared.
6.
And then, is that just this poor little, and then D times D5 is D6. I like it. How we doing? Is that good? Don't start to FOIL things when you don't need to. The only reason FOIL exists is when I have multiplication of 2 things, but I have pluses and minuses in the middle. That gets all freaky. I like that. E. All right. Hopefully this kind of problem is not too bad. What happens here? Yep. Now, one thing I see is, what's going to flip? What do you mean top?
It's gonna go down.
The x's, right? But sometimes I see that 4 somehow, the x grabs, you're coming with me, and it pulls the 4 down. That 4 is being raised to a first power. Why the hell would it go anywhere? It's not a negative power. You guys see what I'm saying? So those 3 x's go down, so I end up with how many x's down here? 7. Does everybody see that? So if you needed, so really the way I would rewrite this is, yeah, they're 18. Those 3 x's come down. There's 4 there, and those 3 come down with it. So of course I end up with 7. I like it. All right. So let's see. Scheisse. F. Who's this guy? Little freaky looking little dude. All right. So you got some of this word times something cubed. They got to do the exponents first. -2 squared, of course, is positive 4. And then what do I do with all the powers?
Adam? No, multiply.
Multiply. So x to the 6th, y to the 10th, z 4. I like it. And again, I'm doing the same thing to this guy. What power is he to? The first. So what's 1 times 2? 2. So I'm going to square him there. So the rules aren't different. It's just dependent on what form it's written in. The rules are actually the same. And then here, of course, -3 cubed. Why does that come out negative?
Because it's an odd number.
Because there's 3 of them, and if 2 of them kill each other, oh shit, let me pick the right ones. If these 2 kill each other, then you have one. So any odd power on the negative comes out negative still. X to the 6, y to the 12, z to the 3rd. And now it's a problem just like that one there, right? I can multiply my numbers together. 108, x to the 12th, y to the 22, z7. Pop. All right, I like it. And then G looks disgusting. We've done a problem like that before. That's really like E, just with more letters. So you just hit the numbers and you hit the letters as they come. Not a big deal. Let's see if you're working. Oh, dude. All right. It's powerful. I want to get a little high. Let's see. G, 12. You're almost too powerful. Black hole marker. -3C. All right. The last part's the part that freaks me out, those C's. But let's hit those up last. Let's see the numbers first, because they act the same way they always have. The answer over here. This is more room.
Divide by 3.
Divide by 3?
4 over 5.
4 over 5. I like it. And then, really, before I do the letters each individually, what do I really look for first? This is my suggestion. You don't have to do it this way. Flip all the negative power things. I like it. So those 4 A's go down. So how many A's on the bottom now? 6. What else moves?
The B goes up.
These 3 B's go up. There are 2 there already, so of course I get B. B5. These don't kill each other because they're not the same thing. Those 3 C's go down, so I end up with 6, 7. Bam! Don't let that be difficult. And of course, H, we did one almost exactly like that one earlier. So hopefully you guys got this thing. I think it's what it says, right? Yeah. What's that? 1. Minus 4 times 1. I like it. All right.
Is that a preset?
I was going to say, I sound like a very mellow ice cream man or Massage is about to start or something. Welcome to the spa. Let me see how many is there. 1, 2, 3, 4, 5, 6, 7. Pretty much just gave the answer there, right? I mean, how many times do you have to move the decimal? 7 zeros. Plus 1. So it's 5.2. You always want to move the decimal until there's one number in front of it. Times 10 to the... Yeah, I had to move it 8 times, and it's negative because I had to move it back. It's a small number. So if I start with 5.2 and then divide by 10 8 times, I become that small. That makes physical sense. That's why it's a negative power. So part B, where'd you go? It's going to be 3.12 times 10 to the 11. Kick ass. Kick ass. They keep doing that thing. Alright. And then 3 is the other way around. This is 1, 1, 3, 10, 6. So I got to move it 6 places that way. Make it big. Twice to get around the numbers. So then how many zeros after that?
4.
4. Because I got to move 6 places total. Bam, bam. And then B, where's that there? It's negative 9.8, 10, negative 5. So how many zeros am I going to have?
6.
4. Once to get around the 9, 4 more times, right? So I'm going to have 1, 2, 3, 4 zeros. So this is 1, 2, 3, 4, 5 total. So when it's a negative power, you've got 1 less 0 in front. Because you always got to move once to get around that whole number. Yes?
We wouldn't get it marked incorrect if we didn't write that placeholder 0 in front of the...
No, this is, yeah, if you don't put that there, you're fine.
Alright.
It's just, you do that so this guy doesn't get lost. Poor little guy. Oh, let's see where I'm at. Oh, 4. Which one of these was not a polynomial? C. It's the only one. C is the only one where a variable has a non-whole number exponent. Why is B okay? Don't say fractions are bad. No, 1/2 is a number.
Because the exponent is not.
Yeah, x is on the top. If it was 1 over 2x, not a polynomial. Because what would that really mean? X to the negative 1, not a whole number power. Oh shit. So any variables on the bottom automatically, no. So 4a is a polynomial. Specifically, it's a binomial. 2 terms. Degree of the first term is second. Degree of the second term is
1.
first. So what's the degree of the whole thing? Second degree. So it's a second degree binomial. Yes. B, of course, is what kind of thing?
Trinomial.
Trinomial. Okay, triforce. It's got 3 parts to it. What's the highest degree I see?
4.
4th degree. Oh yeah, leading coefficient here, sorry. Is 1, because there's a 1 in front of the highest degree term, in front of the a squared. Here, this is 4th degree. What's in front of that term?
Negative 4.
Negative 4. That's the leading coefficient. So leading coefficient, if you put the powers in descending order, which is the normal order to put it in, what's the number that's in front? That's the leading coefficient. So instead of doing the actual work, just look at the highest power term, or highest degree term, and say that's the number. The number in front is the leading coefficient, yes.
How did you get 4th for the degree you have on B?
Oh, B, what's the degree of the first dude? 3rd.
3rd.
What's the degree of the second dude?
4th.
4th. And the degree of the last dude? 1st. So what's the highest degree of C?
Oh, gotcha.
4th. C, we said already, was not a polynomial, so you just don't answer any questions about it. It's not even a polynomial, but nothing applies.
Wait, why?
Because it's not even a polynomial. The idea of degree, the idea of leading coefficient, the idea of all these things applies only to polynomials. He's not a polynomial. So you kind of like want that. Not polynomials, I don't have to answer any stupid questions. Fantastic. Right?
How could you tell? I mean, I had to, like, if I was on a test, like, how would I know if that's not a polynomial?
Yeah.
Oh.
To be a polynomial, every power must be a whole number power. So if I had one that had m to the 1/2 power,
Yeah.
not a polynomial. It's not a whole number power. I like it. So what about part D? I love this one. 7. So how many terms are there? So it's monomial. How many letters do you see? So it's a what degree?
0.
0th degree. 0th? It's a 0th degree. And what's the leading coefficient? It's got to freaking be. It's the only thing, right? It's the leading coefficient is 7. Sweet.
You need your own soundboard.
Huh?
So you need your own soundboard.
Yeah.
Oh.
Kick ass.
Let me see. Before I let you out, yeah, I said that just now.
Press this button. I like it.
Let me ask you this before I let you out. Last thing. I need that too. One more thing. Columbo. What's the fundamental idea behind this problem? If you didn't understand this idea, you could never do this problem. What's the idea?
Combining like terms.
It's combine like terms, right? Now, what's the second kind of level thing? What's being subtracted in this problem? All of this. So what should I do when there's a minus? We know when there's a minus somewhere it could possibly screw us up. I've got to distribute this first. No FOIL yet. So minus 3x squared plus 2x minus 5. And then I can put my like terms together. What I used to do is, see this? Instead of rewriting the shit, just pick different shapes. So then I get no 4x squares minus 3x squares is 1x squared. 5x plus 2x. Negative 6 minus 5. Yes. I'll make it more than it is. Just collecting like terms. All right, that's plenty.